Hi everyone. Um, okay. So the Accenture is a consultant company, international consulting, and also provides outsourcing services. So when we start this project, we evaluate what kind of data we can use from systems that outsourcing companies use, like tickets, platforms, remedies, SAP, and how to extract information from tickets to help the attendants from these tickets to solve their problems and resolve the tickets with uh, speed up better solutions of the tickets. So let's start. Okay. We give a brief overview of business process outsourcing, and then we talk about the possibilities of AI to modernize BPO services and companies. Then we explain our solution, BPO Assistant, and we will give some technical details of the solution, explain how the operation and monitoring works, and how to improve the AI models to using feedbacks of the attendants. So we concluded the presentations with important topics that we learned during the planning of the project to understand very important concepts for artificial intelligence before the development phase. We believe that is very important for before you start to develop some things. You need to take some insights from business understand phase and planning everything. Okay, so business process is a series of steps performed by a group of stakeholders to achieve a concrete goal. These steps are often repeated many times, sometimes by multiple users, and they think about how to guarantee quality on the service delivery, on product delivery. So they think about standards and deliver the service in an optimized way. That business process needs to be implemented in practice for that business. So they're using commonly ticket solutions to acquire the demand from the client, and for each step, the tickets flows in the process for each step, and each attendant can change the ticket with some new information about the problem to the next attendant of the process can solve faster or resolve absolutely the ticket. So business process is well established for many industries. You have manufacturing industry, financial, health, banking, travel, defense, human resources, public sector, compliance, and also we have call centers that already apply business process. So um, we have some challenges that we need to overcome. So we think that AI can help to overcome that challenges. We have bottlenecks. Some steps of the process could be very difficult to solve, or even if the client doesn't describe the demand correctly, it could be painful to solve the ticket. So we believe that machine learning could help to improve and overcome this challenge. You also have lack of visibility, so you don't know how the attendants are growing in the company. So we developed some models to estimate the skills of the attendants given the tickets they had been solved by then. So the overview of our solution is optimization model to allocate tickets automatically. So we need to estimate the skills of the attendants, and based on the historic of solved tickets. And for the new tickets, we already know who is the person with more skill for each problem. So you have an optimization model for provide that allocation. We find the optimal location given the skills and other constraints of the client, and we maximize the capacity of the team to solve the tickets. So no one can be idle in the process. So you need to maximize the capacity of the team. The other solution is a tickets attendance suggestion. So we model the space of the descriptions of the tickets using language models, and we also learn the space of solutions for the tickets. So we train a model to map the problems space to the solution space and give suggestions or recommendations for the attendants given a new ticket. So the attendants also give feedbacks for the predictions, and future use the feedbacks to improve the AI model. So this is the fluxogram, the schema. So we get a list of open tickets, import the data for the cloud, call the ticket allocation services. After that, we call the attendance suggestion services, and then we liberate the data for the team, the attendants could resolve the tickets. It's a very simple schema. And this is more about software engineering. So we have two services. The dispatcher are the optimal location. So you put a pretty name, dispatch services, and we can access the data of the client tickets platform directly from the database or via API REST if the client has a customized. Many clients have their own tickets platform, and others prefer to hire some company, some software, buy some software. So we have data. The data necessary for the dispatch servers are the task distribution, opening tickets, the tickets that are the queuing tickets, doing tickets, ticket solvers, solved, and the team members' data. So we got the historical information about what kind of ticket each one resolved, and we need to learn the skills of the team, and then process the opening tickets to allocate them. So the suggestion services consume the same kind of data, open tickets, doing tickets, and tickets solved. The initial step of these services, we need to acquire that kind of data here. Use the room too. Okay. So you need input data files, could be worksheets or some samples for the database of the tickets platform before the implementation of the models, the services. So we need to understand the business, the data model, how the database have the information that we need. How we can get that information, we need to configure a pipeline to access the data from the tickets platform. And if the tickets platform have an API, how to use the API, how the client needs to provide the credentials of this API to get this information here. You need to request that data before implement these services. So the functionalities here are the client will get suggestion or get a batch of suggestions if they have a batch of tickets to do. And it's almost the same thing for the dispatch service. You have get task distribution, how many problems the company solve. You can get metrics about the allocation, and get the model results are the allocation itself. So following this top-down architecture. We have to work on that tickets allocation. We need to get the list of open tasks or tickets and get list of the available analysts. So some analysts are sick or are on vacations. We need to get the active users and check the average the mean average time of the tickets. So some tickets have to be solved, and some, how can I say, SLA. So we have contract that we estimate. So that ticket needs to be solved in 5 minutes, or we have 1 day to solve, and we need to get a list of these TMAs and feed the optimization model using the skills that we have estimated before. And then we can use linear programming to write a model and build a model for the task distribution. So you have an optimization problem here that you define. So when the models will get start, we need to formulate the mathematical problem, get a list of capacity, TMAs, occupation, SLR expiration, skills, and we need to build the constraints for the model. So you have a lot of constraints of deadlines, priorities, costs for each kind of problem before we start to distribute the tickets. So we have linear regression models to estimate new skill matrix. Skill matrix is just about the number of attendants by the type of problems that we are working on. And the same thing for the mean average time. So the tickets attendance suggestion, we first train the model, so we get historical data, and we get the text content of the fields of the tickets using, we extract some features here, TF, IDF, word2vec, using TensorFlow and sklearning, everything. We categorize the data, so we have we need categories of tickets to learn the semantic of each problem. So we have a semantic for each problem. We can describe the same problem in different ways. So we need to categorize the data first. Normalize and feature engineer to make a fusion of TF-DF in word2vec. Feature fusion here. And we test some models, artificial neural networks, KNN, bagging, and we prefer random forest here inside of ensemble models to combine that features and give the suggestion about the action that the attendance needs to make. So we have 4 different actions, and we need the confidence of each action for the attendants to take the decision. So in production environment, we do the same thing, but not training the data. So we get the production data using natural language processing, extract the features, and that features are itself kind of language model of the semantic of the tickets, and then we classify the tickets to give a suggestion of what kind of action the attendant needs to take. The suggestions are also evaluated by the attendant. The attendant will give the feedback, and future we have another data set, a validation data set on this process. We build a new data set and try to build a new model given the errors registered here. Okay, about the operation monitoring, we have For optimal tickets allocation, we have integrated with tickets platform, so we get the production data and give back to the system that the tickets are already allocated. We generate a lot of reports about the team members for managers, clients, using worksheets or web app. So we provide the reports about tickets allocation, the behavior for each week, for each month, and we provide reports about the skills evolution. So we start with we have some attendants with medium experience and start to solve a lot of tickets and gain increasing the skill on that ticket, so we can plot the evolution of the skill for each attendant. And this is the third one. So we also provide logs report for the client, input data sanity if the production data are correct filled. We have some fields and tickets that could be empty, so we first validate that fields. Then we log about the data volume, just to have notion about what kind of volume we are working for. And the optimization model properties. So what kind of constraints we are considering for tickets allocation. So the operation of the tickets attendance suggestion also integrate tickets with tickets platform or via web app. So it doesn't need to provide the recommendation of the suggestion via tickets platform, just if the client demands. But you can provide a web app to pop up the suggestion. So we also provide reports for managers via web app or worksheets. Ticket suggestion acceptance rate. If the users give a good feedback, we have a report for that. Reports about suggestion confidence rate. So what kind of confidence the model are returning for the attendants. And we also give reports alerting the client to retrain the suggestion model if the confidence start to degrade. When it happens, it's possible that new problems are emerging for the company, and we have to collect more data about these new problems. And we also provide logs report for clients, support data, input data sent, the same thing. It's not optimization. It's about the suggestion. Okay, this is an example of the chart that you generate by the report of the optimization model. So we have the productive per attendant. We have one attendant with this ID. So we code all the problems that the company has. So you have 32 problems. And this blue image here is a, how can I say, a radar for the skills of this attendant. So this attendant is very good for problem 1, problem 8, problem 10, drive 1, drive 2, drive 3. And for the others are not so good. The red are the frequency of the problems for the company. So the company have a lot of problems for 2, for 3, not so much for 5 and 7, too much problems on 11. And we need to compare the ability of the attendants and the situation of the company. So we can compare if you need to train this guy to solve more problems here and here and here and here. So you can have this comparison. So the feedbacks are only for the tickets attendance suggestion. The accepted cases are stored as positive cases of a solution groups. So the rejected cases are stored as positive cases for the correct solution indicated by the team members. So we need to get the positive, the decision after the suggestion to know about the real class of problem. So if you suggest some cases, wrong cases, we need to store the correct solution by the attendant that the attendant give, and to resist as a, I believe it's negative case, it's not positive. No response case are not considered for the data set, so we have not to say. The collected data of solved tickets becomes a new validation set to optimize the model. A new validation error is also important, and the deploy of a new model depends if the new error is compliant with the client metrics. So we need to establish client metrics here, and we also deploy a new model if the new error is according to these metrics. So some things that we notice on business understanding is that every meeting to develop optimal tickets allocation services, every meeting we need to understand what kind of constraints the company have about price, costs, deadlines, priorities, and what kind of variables we need to consider. We need to consider the time of the ticket needs to be solved, the skills of the attendants. We need to define objective function. This is top priority in the business understanding. So if you don't have an objective function, you provide a poor solution here. You need to understand the ticket's data volume, if it's a big data problem or it's a small data size. The frequency of demand is about how many times a day they receive new tickets. So it's every minute, every hour, every day, every week. So you need to understand if that frequency too. And the service type that you want to provide when you allocate tickets. You need to real time or batch service. Batch service is only about, okay, you need to work, you need to allocate tickets every week, because the frequency, it's only, I don't know, 100 tickets per week. So you need to understand the frequency to define the service type. Okay, another things about that are important to understand for tickets attendance suggestion are the problem description on ticket. Where are the problem descriptions? Okay, you have you can have tickets with many descriptions, one for each step of the business process. So you need to get all this data. The solution is the same thing. You can have many fields of solutions, one for each step of the business process. Categories of the tickets, if the categories are related with the solutions or not. And the same thing here, the tickets data volume, frequency demand, and the service type that you want to provide. You want to suggest in real time, so you have a new ticket, you push a button and receive a suggestion, or batch services just solve the demand of the client. So, some questions?
So I see that one of the steps of the model is a linear programming problem. Okay. How do you tackle that? How do you optimize that? Using standard methods like simplex or any other fancy algorithm? How does that work?
So we have a framework to work with optimization problems is Pulp for Python, and they already have, how can I say, a high-level interface to define the problems and the objective function. And I just solve the problem. So this problem is simplex. Possible that it is simplex.
Hi. For a new employer, how can get your skills in and put in a model to put in the program? Existence actual the employer and can imagine your work, your skills. Do they work in close tasks? But the new employer, I can imagine how que tipo, I know something. You put this something that they say.
So it's a very simple solution. We provide a table with the actual problems of the company, and the people that make the interview needs to get the skills of the new employer from the interview and fill the table, and then using API services to insert that skill data on the system, and then you use the pre-filled data.
Okay, so outsourcing means a lot of trouble with GDPR. How are you dealing with it? Are you already compliant? Do you have any tech changes that you plan to do?
Sorry, I didn't understand the question.
So outsourcing means processing other people's data, right?
Yeah.
And GDPR, the European regulation that is going live, it has several specific rules about who owns the data, and the person who processes the data might be different from the person who owns the data, and those two have different responsibilities, but in the end, this has several tech changes that you have to implement. Do you have a plan for that? Do you already?
Yeah, the project is always be done for the owner of the data. So we have approved of the owner. And then we update the system for the company that you can update the system of the other company that is selling their services. I don't know if you understand.
Okay, so suppose a client opens a ticket, and this ticket ends up in your database, and you train a model with it, and everyone is happy, and that the user was an angry European that decided that he doesn't want to be on the database anymore. How does that affect your pipeline?
Okay, if the client that are buying the services are not be anymore in the database.
No, the user of the client, your client.
Okay. Okay. There are many users here.
Yeah.
The users.
I mean,
the employee
the user that puts the ticket into the system. I mean, that's
who opened the tickets want.
yeah.
Okay.
It's the final guy, the guy who has a problem.
Okay. Okay.
I think he's concerned how do you handle information from third parties,
Okay. We don't handle this. We don't handle this yet.
mainly relation probably to GDPR.
Okay. We don't have this problem yet.
It's on to-do list.
Okay. Perfect. Good question.